So we're going to stop taking a look at the circles, and we're going to look at some almost Java pseudocode. I'm going to hand wave a couple things, but otherwise it's going to be Java. And I think it's important taking a look at the way Mergesort looks in code, just simply so that we can get a good grasp of how the recursion works, because Mergesort is a recursive algorithm. Since it's a recursive algorithm, we need a base case. Mergesort takes in a list to be sorted, and it returns a list to be sorted. They are lists of some type t, which is comparable, meaning that we can compare them to another t. So how do we know we can stop sorting? If the list.size is less than or equal to 1. So in other words, if we've got one item or no items, well, that's a sorted list. That sounds like a base case to me, so I'll run with it. Return list. All right, what about the recursive case? So what if we can't end it? So the way Mergesort works is that we are going to split them into halves. We're going to split this algorithm into halves. So we're going to split this list into halves. And then what are we going to do with each half? We're going to merge sort each half and then merge those sorted halves together. Right? Int, so let's see, list t left is equal to left half of list t right is equal to right half of list. Obviously that code won't actually work, but this is, like I said, I'm just hand waving a couple things here. Those things are pretty trivial, but it's more important that you understand the way this algorithm works, and the code should be in the book. Let's see, or you can find it pretty much everywhere. It's a very well-known algorithm. So now we can say left is equal to, now let's see, since it is a sorting algorithm and it is sorting things in place, then technically we should be able to, what, should be a void. Again, we're doing with pseudocode, so it doesn't really matter too much here. Merge sort left. Right, so there's different ways we could write this, but let's just go ahead and go with this way. Merge sort right. So we're going to sort the left half, we're going to sort the right half. Then list is equal to merge sort, not merge sort, but merge, which is a different function, but it's pretty straightforward. It's that method that we talked about that takes two lists, that takes a list on the left, takes a list on the right, both are sorted and merges them together. In fact, you've done that, hopefully, as a quiz or a exam question or a practice exam question. So that is the merge sort algorithm. So we are going to go, it's very short, but it is recursive, but basically it says split it in half until you get to the point where you can't split it in half anymore. That way, so then we've got, if you're dealing with lists of size 1 or size 0, then they are already sorted, so we can start merging those sorted lists together. So let's go ahead and see how this works in implementation-wise.